Similarities of artificial neural networks to the brain. What is a neural network? For a comparison between neural networks and the brain, we first need to know what a neural network is and how it works. This is an example of a neural network visualized, each circle representing an individual neuron. An example of what this network could be used for is the ability to recognize handwritten numbers. In this example, the first row of neurons are used as inputs from the picture, each neuron representing a single pixel in the picture, where the value stored in it is equal to the color of that pixel. The second layer of the neural network recognizes specific groups of pixels, say a square in one area. Each of these areas work by adding up all the numbers of the pixels in that area to get their value. This is then sent to the third row, which works in a similar way to the previous row, but with larger areas that may represent specific parts of a number, depending on how the AI learns. Then in the final fourth layer, each neuron represents a number from 0 to 9, adding up the different parts from the previous neurons to find the most likely number. Similarities to the brain. When the neural network is first created, it is very bad at recognizing numbers, but the more data and time to adapt it is given, the better it becomes. In this way, neural networks are very similar to the brain, as both learn by repeating tasks over and over until it is able to get it right nearly 100% of the time by using the method that works best and slowly adjusting it so that it can become more accurate. However, neural networks can also be seen more as adjusting the values of a quadratic to find the values at the minimum, or the lowest percentage of error, but instead of a quadratic, each pixel is a variable, leading to very low resolution pictures having thousands of variables which can be adjusted. While learning in artificial neurons and the brain can be seen as similar, there are a lot of differences between the way they are structured. While neurons can provide an output and input other than on or off, they cannot be as interconnected, and aren't able to provide feedback to previous neurons, or go to different parts of the brain, with almost all neural networks working in one specific direction and being unable to emulate the complexity of the brain, with its billions of neurons and connections. Uses in modern-day technology. Neural networks have many uses in today's society, ranging from small to massive. Some of the examples of this are self-driving cars, translation, as well as its most common use at the moment, recommending things to someone on social media. All these tasks require is the neural network to be able to recognize that the object in front of it is a car, or what person X likes, and which posts include that, or make a simple translation from the word it has seen to another language. However, as this technology is new and is still getting more and more complex, it's hard to say what this technology will be used for in the future. But it is safe to say it can be used for more complex things, such as more advanced facial recognition software, as well as being able to recognize more advanced images or even language, as it evolves becoming more powerful and closer to the processing power of a human brain.